At Hivecell, we are building small servers for big data. It sounds counterintuitive, but it is the next logical breakthrough. Big data is any data processing large enough that it cannot be easily executed or managed on traditional systems. Traditional systems use a three-tier architecture. There is a server for managing the data, an application server for processing the data, and a client for the user. Since the data sits on one machine, a machine failure means data loss. So the data servers use more reliable hardware, which is far more expensive. As the data grows larger, the server must grow larger, with more memory, more processors, more disk drives, more reliability. The costs go up and up and up. Eventually, the data becomes too big for one server, so we use two or more of these expensive machines to share the work. Unfortunately, these traditional databases were designed and built to work on a single server. Making two or more of these servers work together requires an enormous overhead of management and coordination. And that's just to store and access the data. Processing the data simply multiplies the problem. Traditional applications are designed to run on a single server. As the processing becomes bigger and bigger, so do the machines. Eventually, the amount of processing just becomes too big for one machine to handle. The fact is, traditional systems were designed for one machine. And that one machine, no matter how big, how reliable, or how expensive, has limitations. Making traditional systems work on multiple machines is an expensive headache. That, in a nutshell, is the big data problem. Hadoop is a relatively new open source technology that solves the big data problem. How does Hadoop succeed where traditional systems fail? It was designed from the ground up to work on multiple machines. Hadoop takes big data, breaks it into manageable chunks, and spreads it across multiple machines. That is the distributed file system known as HDFS. Hadoop takes the processing applications and spreads them across the same multiple machines. That is the Yarn Resource Manager. Everything is in parallel by nature. Plus, Hadoop is reliable. Machines fail, no matter how expensive you make them. Hadoop embraces this fact. Since it runs on multiple machines, it can accept if one of them fails. It automatically keeps copies of each file on different servers. If a process fails, Hadoop automatically restarts it on another healthy machine. If Hadoop can work on smaller, less expensive machines, why then are we running Hadoop on the big, expensive machines designed for traditional systems? Hadoop is a revolution in software, but the revolution has only begun. It is our objective to move the revolution forward by providing small servers for big data. Hivecells are small in size, low power, and inexpensive to purchase, but they are not toys. They are simply the smallest practical server for Hadoop in terms of CPU, memory, and disk storage. Our first version has an ARM processor with 2 GB of RAM and a 2 TB hard drive. It is only 3 by 4 by 5 inches and costs around $250. With small servers, you can have the same processing power for half the cost. Not just hardware costs, but power consumption too. Want to be green? Those big servers consume 400 watts or more, while our small servers are a mere 15 watts. Let's compare. Currently, a common server used for big data has 16 processors, 64 GB of RAM, 12 2 TB hard drives, and costs $10,000 or more. A minimum cluster would be 8 machines for a total of 128 processors, 512 GB RAM, 192 TB data, and a cost exceeding $80,000. A cluster of 128 Hivecells provides the same 128 processors, but provides 256 GB of RAM, 256 TB of data, for only $320,000, or 60% less. Plus, the power consumption of the 8 machines is 3.2 kilowatts, while the Hivecell cluster is 1.9 kilowatts, or 40% less. Perhaps you are an IT professional trying to solve your company's big data problem, or a technology enthusiast wanting to experiment with Hadoop, or a university professor wanting to train the next generation, or the data center manager with a shrinking budget and growing demand. We are building Hivecell for you. Simple, affordable, powerful, extensible, and behind the firewall, not in the cloud. Hivecell can help you answer the question, how can we affordably solve the big data problem? Won't you support the Hivecell revolution?